Hello everyone, my name is Richard Boykin. Today I'm going to talk to you about electrical technology and the opportunities of an electrical technician, which is the career field I've been in since I graduated from Jones College. Give a little background information. I'm from Mississippi. I live in Louisiana now. I've been here since 2017 and I'm in my final semester at Southern Miss in the Applied Technology program. Um, It has been a long as I've been in that program since I think 2015. I quit when I moved to Louisiana, and I'm just now getting back to it. And it's been fun with trying to go back to school with Hurricane Ida. Yeah. Um, Currently, I work at Plains All American Pipeline. I've been with them for 4 years, ever since I moved here. They're the reason why I did move here. Um, it's actually been 4 years today. I've been a electrical technician, electronics tech. There's many titles for 13 years now. Just kind of give a little overview of what electrical technician will do. Electrical technician troubleshoots, repairs, installs, uh, calibrates all types of electrical equipment in industrial environments, or it could be commercial, residential. I've typically stayed on the industrial side of things. Some of the challenges faced as an electrical technician is we have safety issues. I mean, there's always a chance of electrical shock or arc flash. I know you're probably aware of what electrical shock is, but arc flash is like when there's so much current, like some very high powered system shorts out, it actually melts and explodes, it could cause severe burns or even death. Also, kind of a work challenge is we have to, we're always, if I change jobs, I'm actually probably moving to a different field or process in an industrial environment. So like I came from Georgia Pacific plywood and I moved to a pipeline company, and there's not any equipment in plywood that's in pipeline, so I had to relearn everything, or well, not relearn, just learn everything and learn their process, and which is slightly different from like maybe a residential electrician who it's when he moves from a house to another house, it's just I'm not trying to bash on electricians, but it's they're working on the same thing. It's breakers, outlets, lights, switches. Um, Educational wise, like I said before, I got my associate's degree. That's pretty common for employers. They always are looking for associate's degree, at least for like electrical technician. I know there's some like apprenticeship programs out there, but yeah, that's typically what employers are looking for. What type of equipment would a electrical technician work on? That could range between motor controls, PLCs. I'm about to get into some of those, but motor controls, PLCs, variable frequency drives, instrumentation, HMI systems, lighting, just about anything you can think of in an industrial environment. E&I or electrical technician would always, they're the ones that's typically working on those. PLCs. What is a PLC? Well, it stands for Programmable Logic Controllers. It's got several components such as processor, I/O, power supply, some communication modules. The processor is the brains, basically. It's the thing executing the program. It's what's interfacing it between it and its rest of its components. I/O the I/O is inputs and outputs. Input, basically the easiest way to explain it is an input would be a light switch at your home, and if that light switch was tied to a PLC and the light as well, the light switch would be an input and the light would be an output. You flip the switch, the PLC would see that the input is true, and then it would tell the program would be written so that it would tell the output to come on, which would be the light. Power supply, that is basically what gives power to everything. Pretty basic there. Communication modules, that is that's the interface between PLCs and a HMI system or other PLCs or computers, or even instrumentation that has communication protocol. PLCs are used for controlling machines, controlling a process. Basically, it's just control. I mean, a programmer would write what it needs to do, and based on its inputs and outputs and maybe what the communication's seeing, it'll execute that. It's used in any kind of industrial environment, any industry out there. I mean, they're very common. And the technicians, electrical technicians, they're typically out there either programming or troubleshooting these on a daily basis, whether that's for a new install or they're having some issues with one. And with that said, I'm going to HMI. HMI. What is an HMI? It stands for Human Machine Interface, and what it's used for is basically, what it stands for. It's the interface between personnel, operations, and machines or a process. This particular one I'm showing you here in the slide is one that actually I did personally. I work for, like I said, pipeline company, and these are crude oil tanks. You can see with the different animations that's probably showing a different level. Not probably, I know it is. Actually, green, I remember it's been a couple years since I did this one, but green means it's moving. So if it's gray, it's stagnant, but green, it's actually moving. And you see started and stopped. So that's actually, so if they can set up batches, the operators can set up batches. So they, let's just say I want 100,000 barrels out of this tank to go into this tank or down the pipeline. They'll set that up by this little screen here. The tanks have strappings, which it means level, and when level is referenced to volume. So if a level is it's not linear, so you actually have to have a strapping table to reflect the volume versus the level. So that's how they base that on their batching, and that's how the tank will know, PLC will know how much has actually came out of that tank. So these are pretty neat. Like I said, they're and this is pretty simple one. There's some machines out there that can do a lot of cool stuff, and this is how the operators are telling the machines what to do. Electronic instruments. So pretty common devices in industrial environments. Electronic instruments can be defined as used to measure an outside force, and convert that to an electronic signal, which would send back to a PLC or something like that. There's many different types: pressure, temperature, flow. So this particular one in this image here is a pressure transmitter, I would assume. I got this off Google, so I'm not quite sure what it is, but it looks like pressure. and it's probably being used as to control. And so it's monitoring the pressure, and there's that looks like a valve right next to it. So that valve's probably going back to a PLC, and the PLC is saying, hey, I want to maintain this pressure, and it's sending a signal to that valve to open and close based on the pressure it's seeing on the outlet side or inlet side of that valve. Temperature could be the same thing. However, it wouldn't be a valve for temperature. It'd probably be some kind of like heating system. And flow, that actually might use a valve. So to control flow, it might pinch back or something like that. So as an electrical technician, you have to be able to troubleshoot and repair these, calibrate these. It can, and kind of go through a little bit of a process, or the process of doing so. You actually have to do several different phases. So, I mean, you have to compare the pressure it's showing versus the pressure the transmitter's showing, and to make sure it's actually reading the correct pressure. Or the electronic signal it sends back to PLC, it's 4 to 20 milliamps, which I won't get into the details of that. But, basically 4 milliamps is zero, like, a typical one would be 4 milliamps, 0 pounds PSI, and let's just say 100 PSI would be 20 milliamps, and that's how the PLC sees it. And then finally the PLC, and it has to be able to read right. So you use different equipment to be able to test that and make sure you're getting all the right pressures and electrical signals. And then if something's out of tolerance, you actually have to calibrate that and have the right equipment and know-how on how to do that. Conclusion. So I just want to talk a little bit about why I love what I do. So it's always a challenge. It's always something new. And I think it's pretty neat when you can make something from scratch, and like I said in the previous slide, and making control something or actually do something from start to finish, whether that's from the pressure transmitter controlling the valve through the PLC and creating a HMI system or a graphical interface that operators can see and interface with that and control that. To me, it's neat. And like I said, the challenge of it, it's always like I talked about before, going to a different field, from a plywood manufacturer to a pipeline company. I just had to learn everything about it, and that kind of goes with it's always something different. I'm never having to work on the same thing every day, so or and do the same thing every day. The applied technology program has helped me tremendously. It helped me with my leadership skills, confidence, kind of think differently, critically thinking. It's just been a tremendous help. And so with that said, I'll leave this. Any questions for anybody? And I appreciate your time. No questions? None? All right. Thanks.